All right, all right. So, all right, just give me a second once more. Great, great. So, in the last session, we talked about the significance of Spark, and we also gave a demonstration. Did anybody try it out? Did anybody try the Spark console? So we have updated this diagram. Earlier it was a little more hodgepodge. Now it's far more better. All right. So so using Spark, you can manipulate all kinds of data from all kinds of data sources on the top of Hadoop. Okay, on the top of Yarn, you can always imagine Spark to be a kind of just a computational framework. It's a server to which you give the computation. It runs on top of Yarn efficiently. It tells Yarn that give me these computers and I have to run my program. And Yarn gives it back and so on. So Spark in a sense provides a kind of a framework under which you run your program. This framework is made up of few things like we talked about called RDD, Resilience Distributed Dataset, on which is basically a symbolic way of representing data distributed across multiple computers. Sometimes RDD means in memory. Sometimes RDD is just a variable which is pointing to some file in the disk. Okay, so that's the kind of way an RDD is. An RDD, resilience distributed dataset, is distributed on multiple machines, although it looks to you as a normal array. Now, there are a few restrictions which RDD pose. RDD enforces that you can only do few things. Okay, RDD provides you two genre of computation. One is called transformation. Transformation is, those functions which do not give the output instantaneously. Instead, they result in another RDD. Okay, while the examples of transformation we give the map and the filter, flat map and group by and reduce by key. And then we talked about actions. Actions are the things which bring data back to the node or make the action happen. So whenever you execute an action, action could be save data to a file, bring data back to me, or do the computation and give a variable. So generally an action brings data back to you. Now actions are the ways of executing the logic, right? In your general cases, when you have say a procedural language, you define a function, right? You define a function that it does something, but the actual thing happen when you execute that function, right? So transformation is more like defining that this is my operation, and action is more like making that action execute. All right, so when you call an action on an RDD, when you call an action on RDD, all the RDDs from which this current RDD has been derived will be executed recursively. Okay, so it's like if you guys are aware about um, DAG is directed acyclic graph. So whenever there is a dependency between things, that I will go to office after wearing shirt and pant and then shoes. So you know that you have certain order of wearing clothes because you cannot wear your shoes and then wear trousers. So that's a dependency graph. So in the brain we have built that dependency graph, as in before going to office, getting ready, the way it happens is that I put on shirt, then I put on trousers, then I put on socks, then I put on shoes. Okay, so if So that's how we compute dependency between various tasks. Similarly, when you execute an action, all the depending uh, transformations get executed. Okay, all the transformations on which the current action depends get executed recursively. So if we have rdd1 which was loaded from a file, now rdd2 is equal to rdd1 dot filter. I think I should make a note of it instead of speaking in the air. All right, these are the notes which will be used in the future class, so I'm just leaving that. All right, so we have okay, so yeah, so let's say you had one rdd which was rdd1 which was loaded from the text file. Okay, some hdfs file or folder, whatever you want to call it. So you say, let's say we loaded rdd from a file, then we had rdd2 which was rdd1 dot say filter. Okay, rdd3 which was say this was your filtering function, your my filter function. So my filter function could be all right, my filter function could be rdd2 dot map. So yeah, map as in clean data, or all right, let me just try to do a few things here. All right, so you can see here rdd1 has been prepared out of the file, rdd2 has been prepared out of rdd1, rdd3 has been prepared out of rdd2. Now when you say rdd3 dot take and you say 10, all the computation on which rdd3 is depending, like rdd2, rdd1, all of these things will get executed. Now imagine for a second that you had one more thing called rdd4. RDD4 is depending on RDD1, and that's a flat map. Okay, and there is some function we have. Yeah, so RDD4 is being prepared by doing the flat map. Flat map means a map that results in multiple values for each element. Now RDD4 is dependent on RDD1, but RDD3 has no dependency on RDD4. Okay, so if I have to draw it quickly, so I'm emphasizing on this idea of directed acyclic graph. So you have RDD1, okay, and you have RDD2, and you have RDD3, okay, RDD3, and you have RDD4. All right. Now you can see that RDD3 depends on RDD3 depends on RDD2 depends on RDD1. Okay, and then rdd4. Now you see that, so when we say rdd1 dot take, okay, when we say things like rdd1 dot take, it will execute rdd1 and rdd2. Okay, it will only execute rdd1 and rdd2, not the rdd4. If we say rdd4 dot take, if we say rdd4 dot take, then it will execute these parts. If we say if we let's say here, if we execute rdd4, then it'll execute rdd2 and rdd1. So that's the significance of this. This is called di- directed acyclic graph. Okay, directed acyclic graph as in it cannot afford to have a cyclic dependency. Say rdd2 depends, rdd3 depends on rdd1, depends on rdd1, right, like this. And what if Here you have something like, again, this depending on RDD. Yeah. Or this will be easier to do, having this. Okay, now you can see that there is a cycle. Although it could happen that RDD4 is also depending on RDD1. If we are this RDD4 is equals to RDD2 dot RDD1, RDD2 join RDD1, then it could be this kind of graph. This is valid, but having the other way is not valid. This is not valid. Okay, you cannot have this. Okay, because it's a cycle. That's why we call it a cyclic graph. All right. So these kind of data structure called directed acyclic graph are of various importance. They come into play when you talk about running a build script, running a project plan, and when you talk about things like even Git uses a cyclic graph a lot. Similarly, in the Bitcoin, when you have the Bitcoin chain, it's a graph of transactions. It's a directed acyclic graph. There is no cyclic dependencies. Okay, so I think Bitcoin does not have multiple dependencies. It's more like a big graph. Anyway, so there are it's computationally it's very significant. It's a very significant um, all right. So this is what it is. All right, now uh, in case of transformation, we define this dependency. When we say this is my transformation, when we said RDD1 is equal to this, RDD2 is equal to this, RDD, these are text file, map, filter. Text file we cannot say transformation because it's loading. So map, filter, flat map, all of these are transformations. They are transforming one data set to another. In a sense, by the way of these three statements, have created this graph. So creation of this graph is done when we define the transformation. And the moment we say take, then the actual execution will happen. Then the actual execution will happen like this. Okay, so this is when we say rdd3 dot take say 20 element. Okay, so this take is an action which is making things happen. All right, Sushant, is that clear? No, take brings data back to the user, the caller, us. While RDD1, RDD2, the way we have created, they don't do anything. Just they make a note of it in the form of this graph saying, oh, let's draw a graph because you have defined RD2, and we draw an edge between RDD2 and RDD1 saying how to reach to RDD2 from RDD1. Okay, does it make sense, Sushant? No? All right. Yes. So yes, you are right when you say, okay, we need action to actually execute and retain the things. Yes. It's like action is like pressing enter. Okay. While writing transformation is like drawing a graph. Okay. So when we want to get the results, then we need to do an action. And there is a purpose of having this lazy behavior. So we call it for Spark, we call it a lazy behavior because it doesn't do things instantaneously. Instead, it does things when we say an action. So Vina's question is, so before take, is it allocating memory too? No, it's not loading data into the memory. So here, when I say RDD equals to sc.text file, it does not mean that we are loading that data into memory. No, it's not doing anything. It's just marking that to reach to an RDD, we need to have this text file loaded into the memory. Okay, and then when RDD2 says that okay, to reach to RDD2 from RDD1 we have to do these operations, so it keeps on making notes. When we are defining a transformation, it's not doing anything, it's only allocating memory for making these nodes, few bytes of memory to making these nodes, nothing more than that. All right. Yes, it's more like kind of the the way we define functions. Unless we call the functions, nothing happens. Okay. All right. So this is a very valid question from Susant. So yeah. So here we talked about two things. One is transformation, other is action. In our usual logic, what happens is things get executed as and when a statement is encountered, right? But here, when we say transform my data from one form to another, in that it doesn't get executed unless you call an action, something like action like take, collect, count, or reduce. There are many kind of actions which are done. Now question is, why do we need this kind of behavior, and why did we need this kind of behavior in pig? Right, if you remember pig, if you tried running your programs in pig, you will know that the in case of pig, the stuff happened when we said save or dump, right? Store or dump, not save or dump, store or dump, correct? So why do we need such kind of lazy behavior? That's a very important question. Now if you remember, if you think about it, if you say, here, let's think about it for a moment. Let's say we have RDD 2x equals to RDD2 dot map, and then we have uh, extra clean, okay, extra clean function which will clean one more layer, and then we have this. Okay, so let's say we have this kind of model. Now if you look at it closely, map this clean and extra clean can actually be combined in a single shot, right? So these two statements can be actually combined. So if you have this kind of a graph, it gives an opportunity for Spark to do lots and lots of optimization in the way things are done. Okay, it gives a lots and lots of opportunities for Spark to get things done. Also imagine that if we did this, we said RDD1 equals to this, right? And it created a memory at this point of time. Now here you are sitting idle, you are not writing the code, and still it has consumed memory. Okay, so that's not something which is acceptable. So so that is why, to optimize those steps, it is decided to have the lazy behavior do when we need to do instead of now. Make sense, Shushant? So there are two, three things we did. One is optimization. Second, utilize resources only for short period of time. Okay, by combining multiple operations together. All right. Although if at point of time you realize that this text file is something you want to do really fast operations, so what you could do is, here at this point, if you say rdd1 dot persist, okay, so when you say rdd1 dot persist, it will bring data from the file, load the data from the file, and put it in the memory. so that this RDD1 is available in the memory for the future operations. So all the future operations on RDD1 will become extremely fast because there will be no file loading involved. All right. In this case, if you say rdd1.persist, in this case, it will load into the memory and memory will be consumed. That was Veena's question. Very brilliant questions. All right. All right. There is a Sridhar's question. Now, here, question is from Sridhar, like RDD2 will call RDD2. So let's say here we could have another RDD2 equals to RDD2 dot filter, right? That's the thing are you talking about? So if we have this kind of thing, this old behavior of RDD2 is overwritten. Anybody who depends on RDD2 will will talk about this RDD, not this RDD. Okay, in future from this point onwards. Okay, so RDD2's definition will be overwritten by this. So RDD2 for them has got changed. While for this guy, this RDD2 is equal to RDD1 dot map. Okay, for this RDD2, these people, RDD2's meaning is this RDD2. Okay, so I hope that clears the idea. It's like pointers, juggling the pointers between the things. Variable definitions. So Randir's question is it, doesn't it become the cyclic? Not really. Okay, not really. Okay, so you should try it out. You should try it out. Once you try these things out, this doubt about RDD2 and RDD1 will become very clear. All right. So when I say RDD2 equals to RDD2 dot filter, it's you can think of this way. It's basically equal. These two statements internally will get combined and will look like this. It'll look like this. I'll try to do it. So here it'll be like this. All right. So previous RDD2 has been overwritten. So RDD1 dot map clean data then filter this. Yes, you should try it out. I think this is a very genuine doubt, and the only way to clear it is actually trying it out. All right? Did I make sense, Shushant and Sridhar? All right. There are two more good questions from Shushant. The question is, all right. Let me just take this to the top because it's confusing me. Okay. All right. Now there is a question from Shushant. So question is, so this RDD in the memory and RDD logical reference. Yes. So RDD is actually both the things. The moment you say RDD1.persist, it becomes the actual data. While when you don't say persist, it's basically pointing to the file lying somewhere. Okay, it will create the pointers to saying, okay, data block one. So let's just imagine for a second. I think this is a very good point you raised. Let me try to describe it this way. Imagine that you have three data nodes. Okay, imagine that these are three data nodes. Let's see that. Okay, so block one, block two, block three. These are your three data nodes. Okay, these are your data nodes. Okay, of containing a single file, block one here, block two here, block three here. Your file is built upon three files. Okay. Now, what if you do things like this? Okay, like here. All right. Here. Now this is your RDD. Let's say you are saying RDD1 equals to load my file. Now it will find out the same nodes. I'll just increase the size of these nodes like this. Okay, so you can think of this RDD is actually on three nodes. Okay, here this is node 1, node 1 and node 2 and node 3. Okay, so RDD1, which is basically an array, is divided across three nodes. This this section of the RDD, these few elements, I think I should draw it really nicely. Okay, this is okay. I think describe. Just be with me for a second. I'll try my best. Okay, so this is say one element, this is say another line in the file, another line of the file, another line of the file, another line of the file. Okay, so like this. Okay, so these are the sections, we call it partitions of the RDD. They are pointing to each individual blocks. Okay, right now there are these sections are pointing to these individual data nodes. So, so when you say persist, that data will be brought here and kept, some data here, some data here, some data here. Initially, there'll be only pointers on the same machine. And when you run your logic, say you create another RDD, that RDD will be on the same nodes like here. RDD will be on the same nodes. Okay, this is our RDD2. So think of RDD2 as being converted from the. So you can think of RDD2 has been converted from RDD1. Okay, now this set of data will give this set of data. Okay, this set of data will give this. So you can see what's happening here in RDD1 and RDD2. The transformation will minimize the data transfer. Okay, so what's happening is, by the way of Spark, you are able to optimize on these things. So, and how is Spark able to do all of this? It will ask the name node about the data locations, and then we'll go to Yarn and tell, hey, you know what? I have my file on these locations. Can you tell me available node managers on these things? Okay, so here these are node managers. So generally, since node managers are near the data node, and in our case, same machines which are data nodes are also node managers. All right. Do I make sense here? All right. Good set of questions. So there are a few more questions. Let me explain. All right. There are two more questions. All right. So one is, how many maps and filters can we do at a time? As in, let's say maps and filter, as in hundreds of transformations you can write before calling an action. Okay, that's pretty much okay. If your graph, this dependency graph, generally takes a very small amount of time. Okay, it takes a very small amount of time, and as well as memory. So you can create the these transformations as long as your graph doesn't grow beyond the memory allocated by node manager, or for the driver as in the place from where you are launching your the script, your program. Okay, so next question is, what will happen if you make it cyclic? That I have not actually thought so far, but let me try to make it cyclic. Let's try to do rd1 equals to sc.text file. Okay, how will I make it text? Let me try. Let me try. Can I make it cyclic? All right. Let's say we have this. RD1 is this. RD2 is this. RDD2 is RDD1.map, and so on. Now, what if RDD1 equals to RDD1 equals to RDD2 dot filter, RDD2 dot say some map, okay, and then we say RDD1 dot take, okay. What will happen in this case? This is interesting. I need to think about it. So RDD1 we loaded from the file. Now RDD1 we have, RDD2 we have defined as RDD2. Let me just make it one more here. All right, all right. So it will, I think, I'm just guessing, I'm just taking a guess. So if you think about it, it's basically RDD1 dot, I think this would become something like this. I think this will become something like this. Okay. So load the text file, do the clean data, and then do the map. I think this will look like something like this. All right. Yeah, this is interesting. I need to do it, and only then I'll be able to say anything. Okay, so what my theory here is that it's basically equal to saying sc.text file, okay, then run this map, okay, and then and after this run this, okay, and then run take. All right, so something of this sort. This is what it will end up. I don't know, honestly. I don't know. Okay, let me try it out, and so my hypothesis is this. All right, we should give it a try, maybe at a later point of time. All right, so doesn't look like to me an infinite recursion, but I should give it a shot. It all depends on how well Spark guys have implemented their thing. All right. Because the way when I look at this, all I'm seeing is that they created in the graph, when they started something of this sort, they will first basically create a kind of node for sc.text file. This is sc.text file, and then we will have we'll have another node for map, which is basically depending on the outcome of previous node. right? So this graph is being constructed as we keep on moving further and further. So here when we say sc.text file, it got loaded, then got map.clean data. Okay, so you can think of map.clean data, then extra clean data, and you can think of extra clean data, and then got take. You got take. Okay, so you can think of this and this. Okay, so this is how I'm looking at it. I don't think there'll be a recursion. All right, very interesting questions, and I think I should just save these graphics. All right, great set of questions. All right, let's just move on. So, is it clear the way execution happens? Brilliant, brilliant. So, other than transformation and action, and so RDD transformation and action, then comes the other kind of construct such as broadcast. Broadcast is like common cache in which you can push the data to all the nodes. So want if you want certain data to be available to all the nodes, right? Like a static variable, right? You if you remember, you used to have a static variable in your program. If you put some data in a static variable, it's available to all the threads and it's available to the whole memory. Now that static variable doesn't make sense here because your program, whatever functions you write as part of transformation or action, all those static variables are only specific to one process, one particular machine. Here, same code, whatever you wrote in transformation, is going to be run many times on many threads, many cores, and many machines. Therefore, the idea of static variable is no longer valid. That's where Spark has to come up with something called a broadcast. So it's a common cache in which you can push the data and make it available to all the nodes at the same time. Now sometimes your nodes need to inform about their progress back to the driver is your code, your launcher, from where all these transformation and action are being executed, from where your program is being executed, that is the driver. So from driver, if you want to report the progress from all the nodes, then you use the driver. Okay, and so if you want to gather statistics or gather numbers, gather progress from all the nodes as and when your mapper, your transformations and actions are happening, you use accumulators. All right. So there were two examples. I suggest that you try executing them line by line. Change this to h1.no cloudx lab because this location in HDFS file does not exist. Or you give a location to your file. Okay. You could also give things like data slash mr slash word count slash. This is where you can have a look at, you can take a look at you can take a look at the HDFS. That will give you a better idea. Okay, so something like this you can do. Okay, you can read it, then you can save data here. If you provide just some kind of XYZ, it will create this XYZ folder in your home directory in HDFS. Okay, now let's talk about. So Veena's question is, will there be three copies of broadcast data in HDFS? No, the broadcast data doesn't go into HDFS. Instead, broadcast data stays with the Spark process. So Spark process is running inside Yarn, and basically, if you remember our description, it's a good question. Okay, so let me just try to show you. I know I have a limited time. I may run out of time. So here you can imagine that you have three nodes: node 1, node 2, and node 3. Okay, so, and this is your driver. Now driver is the one where you write the code and you send the code. So this driver talks to the yarn. So these are your node managers, and there is an application master inside the driver manager. There are two parts. One is application master. Okay, this is your application master. It's called Spark AM, meaning Spark application master. Okay, so this kind of thing exists on all the nodes. This kind of thing exists on all the nodes. Node 1, node 2, node 3. These are node managers, okay? If you remember our yarn discussion. So these are application masters. And now inside each is your process running, in which the in which there is an memory located for RDD. These are your RDDs, parts of the RDDs, multiple of such things, in which the computations are happening inside the container. There may be the you can think of here the logic is being running on all these machines, okay, and so on. All right, so this is what is happening in case of Yan. And also the broadcast is also one kind of a memory located here only, everywhere inside the Spark application container. All right, so the Spark the driver will keep on sending the broadcast to all these application masters, and hence to all the containers. Okay, so this is how the memory. So also please note that these broadcast is only in memory, not in the disk. Brilliant. Great, great set of questions. All right, and all right. So again, Sushant's question is that what is the use of broadcast? Broadcast is used for sending out data to all the nodes. Now your question could be that what's the point of having a broadcast when you have HDFS? You could have put your data in HDFS and then load data on every node everywhere, right? But this is small data. You want it to be loaded. Okay, like if you remember when you define a variable, static variable in your code which need to be sent to all the nodes, then you can either hard code those values or use put it in the broadcast. So instead of static variables, you use broadcast, meaning some small data which you want to send to all the nodes. For example, here in this case, you look at this data. So this is what we want to remove common words from the file, right? So here in this example, we are removing these common words. We realize that while doing the word count, we should not be counting the words which are too common, right? Therefore, we remove these common words. Now, this memory, this common variable should be moved to broadcast so that it is far more efficiently pushed to all the nodes. All right, good, great. Now, a little bit more theory. All right. So I'm generally repeating my sentences. I'm trying to make it such that in case you miss out on past, still you should be able to catch up things. Okay, brilliant. All right. So now let's talk about Spark streaming. What does it mean by Spark streaming to all of us? Okay, okay. So imagine this. You are having this great e-commerce website, and when on your website, when people place an order for something, that request, that information has to be sent to multiple teams. Your company might be having 50 different teams which handle different things. Say, for one team, they take care of availability, while the other team uh, take care of the logistics of delivery, while the third team takes care of checking whether this purchase was a fraud. Fourth team takes care of the SMS and and emails, right? Similarly, there are different teams which are trying to do different things based on the as the order is placed by the customer. Okay, and this is a real story from what we did at Amazon. Also, there's an analytics team. What the team wants to do is it wants to show it to the CEO of the company that how many orders are being placed every second, or what is the total value being uh, the total revenue that is coming to the company every second. That's the thing you want to do. As and when the orders, so you have millions of products being sold on your e-commerce website, and you want to see it in the real time, as well as there are so many teams who are doing different things. Now, how do we achieve this kind of flexibility where every team has this opportunity to handle to take a call, to get notified that a purchase of this value for this item has happened by this kind of customer, right? For that we need a centralized event bus or a queue. In case of Amazon, we had SQS. In case of Amazon, we had SQS, and in SQS, on one hand, the people who want to generate the events will push the data. From other end, people listen to the data, and that's the big use case of a queue. So I hope the idea of a queue is clear to everybody, right? So you can always imagine that you have got really big queue. So let me just try to, okay. All right. So you can imagine that this is your big queue. The order got placed. Okay. The order details are pushed to it. Similarly, there are other events coming in. Okay. The order details are being pushed to it every minute. Okay. And then on the other end, there are different listeners who are reading from it. Okay, there are different listeners who are reading from it. Okay, now here you could be going to say the delivery team, availability team will update that this item has to be deleted, its total value has to be decreased. Similarly, there'll be another team who will resell team who will send the recommendation to the user that, hey, you bought this, congratulations, maybe you will like to buy this along with this. And then there could be another fraud detection team. They're all reading from this end of the queue, and more orders are coming from this side. Okay, so in an organization there could be hundreds or thousands of such use cases. Okay, there could be hundreds of thousands of use cases of a queue. All right. Now, one of the use case could be analytics. Analytics such as give me uh, give per second order flow. how many orders are being generated per second. For example, if you go into Google Analytics, you will see how many users are there on your website right now. Okay, all right. So that's where the streaming comes into play. This is called streaming. Stream processing the data which is coming at a very fast pace. Streaming here in this context does not mean video streaming or YouTube video watching. It means streaming means here the flow at which the churning the real time data. Now, Spark streaming along with other tools like Spark streaming, there are other alternatives to Spark, which are Storm and others. There are many such systems which help you in churning the real-time data. Now, how does it happen? So basically, Spark streaming is nothing but a very thin layer on top of Spark. So some people realize that the Spark is fairly fast, and they can utilize the idea of RDD to churn data in real time. So all it did was, and also note that in case of Spark streaming, we churn the data input and convert it into an analytics and push to various sources. So the way you can look at a Spark streaming is the input data is coming from the stream, and then Spark streaming library. This streaming library is a very simple code. All it does is it reads data from the source, then it pushes it to RDD. Okay, creates many RDDs, one RDD per second. So whatever batch size you define, if you want to say, let's say if you want to consume data such that you want an output per second, so you will create batch size of 1 second. So Spark streaming will create batch size of 1 second. And what does it mean by batch size? It will internally convert the inflow of data into many RDDs, each RDD for 1 second data. All right. So, and then on each of the RDD, it gives you the ability to run your transformation and actions and and give the results. And that's where the Spark engine comes into play. That's where the Spark engine comes into play. So Spark engine is basically being called via Spark streaming library, and you get the batches of the output process data. So the workflow is Spark streaming receives the live input data streams, divides the data into batches. Spark engine generates the final stream of results from the batches. And these batches, each batch means one RDD. Inside that, operations which you define on Spark streaming are being going to be called on every RDD being generated per second. All right. So you can see that a D stream is a library which is creating data per second. So when you are defining an instance of the Spark streaming library called dstream, dstream is the heart of Spark streaming. Spark streaming is a general word. Dstream is the class which handles this whole game of streaming. So dstream is basically, while creating an instance of dstream, you tell the size of the batch in terms of how many seconds. Okay, how many seconds is what you tell to dstream. Now dstream will pick up the data from that particular points and put the data into the batches, and then On each batch, your the transformation and actions will be executed, and the result will be saved in the output. So your code, your action is being called again and again on each RDD, and transformation will be further called on each element of the RDD. Okay. Now further, Spark also provide you further group these batches of data into windows. At later point of time, you realize that fine, we had this per second batches. You want to combine multiple batches together in the, and this can be done using window operation. So say for example, we have this RDD called pairs. RDD as in D stream RDD. So we can say reduce by key and window. Okay, so you can define a window of this duration, and basically you can define two things. One is the window size and how much you want to repeat it. Okay, if you want the different this and this different, then the data will be repeated, so it will reduce last 30 seconds of data every 10 seconds. So that's a window, sliding window operations. Okay, so all right, Sushant's question is, stream is the stream of memory references or stream of actual data? It's an actual data, it consumes memory. All right. Now let's take a look at it. I won't be able to give you a demo right now. Okay. All right. So the step one is you. So the objective of this exercise is to do the word count every second. You want to count the words every second. So the so this code is in Java. Although I have a Python one also, but I have not mm, made it very specific for this example right now. So I will share that Python video with you as well. Also, yeah, I'll let you know with that video. Now let's have a look at it here. What's going on? Here we are saying Java streaming context, and we are saying that we are creating a batch of 1 second. We are saying Java streaming context JSCC. This is the object of this class, and here is the constructor which creates this object. And this constructor, we are telling that hey, this is the name of our stream engine. We want to give any abstract name. This is also the name, and this is your duration. Okay, meaning I want to do the processing of data per second. Meaning our RDD, individual RDD will be created per second. Now, here I'm saying what does it mean by our opening the data? So here we are saying lines equals to Java socket D stream. Here we are saying that pick up the data every second. All right, that's what we're saying. Pick up the data every second from localhost listening at this port. Okay, so it will keep on listening for the data at this host at this port. All right, and after reading data every second at this host, as here localhost and this port, this will open a socket and will start reading whatever data comes to this port, and then we'll start creating internally an RDDs for every second. And that encapsulation, all of that complexity is hidden from you. It provides you lines, which is very analogous to, this is very analogous to RDD. This is D stream, not RDD. So lines, it gives us lines, which is a D stream, and on lines you can execute all those kind of functions like map, flat map, and all of that. And all of these functions are going to be executed on every RDD which is created every second. Okay, so you have, we are having the flat map breaking down the lines into words, and then you have map, which is basically converting the each word into key value pair. And then you have reduce by key, exactly in the way we did the computation of word count, where we are calling a reduce function. This is a reduce function in Java. And here the word count is similar to RDD, but it is not. It's a D stream, which is a collection of multiple RDDs. Now, if you say word count dot collect, it will be executed. This collect is going to be executed every second. So when you say print here, word count dot print, this print will be executed every second. Okay, the sprint is going to be executed again and again every second. Okay, so that's the difference. That's how it happens. So Sridhar's question is, will yarn have enough memory to process streams of data? So since the memory is divided on multiple machines, it should have enough memory combining the RAM of all these machines. So it will actually give a big hit to your machines. Okay, keep that in mind. So yarn will only give the nodes which have enough memory. All right, good question. And that's the reason why people avoid lot of stream processing on their cluster. Generally, for the stream processing, when stream processing start consuming too much of memory, they have a separate cluster. Okay. Now, this is the D stream. D stream is a collection of RDDs. This is one RDD, second RDD, third RDD, fourth RDD. And then when we say print, do flat map operation, do reduce by key on this and say print, then the word from time 0 to time 1, the frequency will be printed every second. And that's all about stream processing. All right. So that was our discussion on stream processing. Any questions at this point? Question is, looks like streaming is running in memory, so this cannot be used by HDFS static data. So I'll explain to you this. So here, streaming is run out of memory, because run in the memory because we want immediate results. When we are talking about seconds and milliseconds, we cannot afford to use disk. And on top of this, we cannot afford to have system like SDFS because it'll take a lot of time to persist each byte of data. But if we want to combine the data which is located on my HDFS against this data which is coming in the real-time feed, we can happily do that. We can happily do that. We can join that against our D stream. All right. We can definitely combine our these words. Let's say while doing the word count here, you want to remove the words which are existing in the dictionary. Now, the dictionary is, say, lying in your disk, right? So you will load the dictionary from the disk, keep it in memory ready to be uh, to be checked against each RDD. All right, sounds good to you? All right, so that was our discussion on streaming. Any questions at this point? All right. Good, good. Yeah. All right, brilliant. So now let's continue with our discussion on the usual tools like Scoop and Flume, and yeah, and then get into those details. All right, so let's start with Scoop. All right, all right. So let's start with the. Now here we are. All right. So what exactly is scoop? In very simple words, when we have to pull the data from the structured relational database like MySQL, Oracle, or MS SQL, or Postgres, or other databases, when you want to pull the data into HBase, into Hadoop, meaning Hive, HBase, HDFS, then you generally need to read the data from these databases and put it here, right? So you could as well have written your own code to do that, S- right? But when we talk about big data and you have got your data in a very big table in the relational databases, your script might take a lot of time, and that's when the MapReduce comes into play. So scoop is one such example where you read data from these SQLs into the structured into your Hadoop via maps and reduces. Okay, so Scoop is an open source tool. It extracts data from structured sources into Hadoop for further processing, can also move data from DB to HBase, can export data back to the data store, okay, and has an extension framework called connectors. Now, the question from the question from Susant is, what is the advantage of pulling structured data into HDFS? The advantage of pulling structured data into HDFS is that sometimes you need to process this data and combine this data with your big data and do the output. Let's say your table is dependent on certain data which is lying in your MySQL, or let's say at certain point of time you realize that your organization need to move to HBase. Okay, your organization realizes that you have to move lot of data to HBase because your MySQL or your SQL database is no longer sufficient, or certain archives of data you want to empty it into Hadoop so that it will have a great backup, it will have more efficiency and performance. Okay, so for those cases where you don't require too much of relational, but you require a great redundancy and replication, you want to move that data to HBase, so to Hadoop, sorry. So those are the advantages of moving data from structured sources into HDFS. Okay, so it provides you a tool called Scoop, and using Scoop, you can do all kinds of magic. All right, and it provides you connectors. Connectors means it's basically a modular component that uses kind of extension framework so that you can import and export from any data source. Okay, although every database which has got a JDBC driver, if you can connect to the database via Java, via standard Java driver, then you can connect to, you can connect as a scoop to that. But let's say there is a new database for which there is no Java driver. In those cases, you can create connector, and connector will do that work. Okay, so you don't have to worry about, you don't have to worry about writing code to pull the data from scoop into Hadoop. Okay, pull the data from MySQL or any structured uh, sources to the Hadoop. Okay, so there are the connectors for almost every database on planet is already there in Scoop, so you don't have to worry about that. Yes. So Siddharth's question is same will be done by the ODBC connector. So this extension framework by default provides a wrapper on JDBC connector, not ODBC connector right now. ODBC connector is great for Microsoft languages, but Scoop is written in JDBC, sorry, Java, so it generally needs a JDBC connector. But I think they have written a wrapper which can translate a ODBC driver and some sort of those things. All right. Now, let's try to do a sample import. Okay. Let's try to do a sample import. And for that, what we are going to do is we should have a MySQL installed on a machine. Okay. We should have a MySQL installed on the machine. All right. Let's try to run this. And also note that this process of importing data to Hadoop is parallel. Parallel in the sense that some rows will be taken care by one mapper, other rows will be taken care by another mapper, and so on. That's how it will divide the work amongst itself. All right. So now the big time. Let's try to log in into the terminal. Good. It is opened. Now let me just key in the login. Now the password. Let me key in the password. Alright, I have logged in. Increase the font a little bit so that all can see. Alright, so now going back here. So I had done. Alright, I will just try to connect to this machine. I'll say MySQL minus minus help. Okay, how do you connect to? So minus U means user. Okay, sorry. Minus U means user. So scoop, so not scoop, MySQL minus U, and my username is scoop user. So I'm right now trying to talk to MySQL so that I can create a dummy data which I can import. Okay, so for that I need to start with MySQL command line. Okay, I'm saying MySQL user is scoop user, and then I want to find out the host name. How do you define the host name in case of MySQL? All right, where is the host name? Minus h. Okay, so minus h. So the host of this database for MySQL is c.cloudxlab.com, and then let's try to run this way. Okay, Alright, let me feed the password also. I'm hoping this password will work. Oh, this is not the password. It's basically, I think, port. Alright, now we are connected to the MySQL on this particular host. Okay, this particular host. And sorry, how did we connect? Let me parallelly update this slides so that you can try by yourself as well. So that was our enter password as okay. So that's what we did. Now let's try to update it here. Okay, so we are going to create a new database for ourselves. Okay, so we log in here. This is not required because the MySQL is already running for you, so you don't have to worry about that part. So we are connecting to the this one. Now let's try to create first let's have a look at what is going on with this. We say show databases. So there is only one database already there called ScoopX. Okay, so I have already created my database. In case you have not created, you can do that. Anyway, let me try to create this, create database. So I don't have the rights to this creating the database. Can I just do a scoop ex show tables? I hope I'm able to create tables. So we already have something called this widgets. Can I say create table X? And it has got, okay, show tables. All right. So now here we have got this. All right. So whenever you are creating a database, if you're creating a fresh database, although here you don't have permission to create the database, but if you're creating a database in production, if you're creating database in production, that, keep this in mind, very important part, what exactly is going on here. We are giving the permission to all the hosts to access this particular database. Why? Because when we will run the scoop, you never know where your mapper is going to run, right? Your mapper would be run on any machine which is free, because here there is no HDFS file involved. So the decision on which mappers to utilize will be solely based on which machines are free. So when you define number of mappers, you tell explicitly that I need these many mappers, but I don't have an HDFS file. In those cases, Yarn will give you the machines which could be anywhere in the network, right? Therefore, you have to make sure that you give the to permission for your database to be accessed from anywhere in the network, right? Meaning, no matter which machine is running your is trying to connect to your SQL database, it should be, because when you do the scoop import, it will import data using MapReduce. So your importing code will be running connecting to MySQL from all the hosts or maybe any host. Therefore, we have made sure to give the permission this way. Here it will be cloudxlab.com instead of no big data. This code is little older. All right. So that's it. Now we have this database here. Okay. So we have show tables. Already we have created this select star from widgets. Okay, we already have created certain data in this widgets table. All right, now let's just check if we are able to access this particular host from some other node. Okay, we are anyway able to access this from E while uh, the host is C, we are accessing it from E. Therefore, we should be able to access it from elsewhere as well. Okay, so good. We have our data ready for being imported into the into the cluster. All right, let's start with it. Now, all right, this is running fine. So good. So we have created this table by default for you. We've inserted this data so that we have something to import. Now is the actual command. So what we are doing here is we are saying, we are telling this scoop saying scoop scoop is the command, scoop import, and this is the connection URL. We are saying c dot cloudxlab.com, and then our database name is scoop ex and table name is widgets, and we are saying here only use one mapper. You could use say 100 mappers. If you have 100 nodes, you could use 4, or if you have 100 capacity, total number of tasks that could be run on your cluster are say 100. If you have 50 nodes and each node can run 2 tasks, then you can say mapper 100 and run it. And then you provide the host name, the username, and the username for this was scoop user. Scoop user, and the password was this. Good. Now let's see if it can import our table into HDFS. Sounds good to you? All right, let's try to see if it is doing something. And by default, it will take this table and put it in your home folder. You can change that at any point of time. So we are saying import. Is it connecting? I think it is connecting. What does it say? Outlooks. Okay, let me just see what's going on here. It says it is owned by HDFS user. All right, let me try to remove it. Let me open a terminal. I need to understand this. Why is it happening that way? SSH, SSH, and I say, what is the node? E dot cloudxlab. This time I'll log in into some user who can do some administrative activities. Okay, so this is my user which can do administrative activities, and so we can see ls hadoop fs minus ls user slash sandeep giri 9034. Okay, all right, so it shows that all of the folders in my home directory are owned by Hadoop. Okay, owned by HDFS. So how do we change these permissions? You can use HDFS command. We can say Hadoop, and we instead of ls we could say change owner. Okay, I'm trying to change owner of all the folder under this. And who do I want to change the owner to? I want to change the owner to this guy. Now it will say that you are not allowed to do this. It says it is giving some other error. I think it expects the minus R. Okay, it is saying that you are not allowed. So we'll say sudo minus u hdfs. So I'm running the Hadoop fs command from hdfs, which is sudo. Alright, now if I go back to my previous command and check what's going on here, it should work fine. You can see that. Okay. So, alright, now let's give it one more try if it can do something here. Let's see what error do we get this time. Saying that the URL to track the progress is this, meaning it's actually running maps and reduces. Alright, so it has done the work. It is saying, okay, did it give us the number of what directory output? Alright, where is the output directory? Never mind. So it'll be created there. If you see above, let's go back, go up. Where is the Hadoop fs minus ls we were doing? We were doing Hadoop fs minus ls. So it had hive jars, staging, my workflow, my data one, Uzi. Okay, now let's see Hadoop fs minus ls. All right, so yes, there are two questions. Let me answer these nice questions. And but before that, let's have a look at the result. So it has created this new folder. You can see the time on this. It is just created now. Okay, and staging was also touched. So here is the widgets. We can see Hadoop fs minus ls widgets, or you can see it through the hue. Okay, so it has done in three parts. Okay, unnecessarily it has done it in the three parts. Never mind. And I'm still wondering what made it do in three parts. Oh, we actually defined mapper as 100. Do you see that? Okay, we actually did the mapper as 100. So, even though I have a total number of records as 3 in the file, we still defined the mapper as 100. Okay, so that's why it has done the job as like whatever maximum distribution it could do. All right, there are these brilliant questions. So let me try to answer these questions. So one question was who is responsible for giving permissions on all hosts in terms of an organization? So generally sysadmin, or we call them the DevOps team. All right, all right. Now, what is sudo? Sudo Okay, sudo is an interesting idea. So I'll show you. This is my, there are two users I'm logged in as right now. This is Sandeep. Who am I? It shows Sandeep. Okay. And here it's, I say, who am I? Here, who am I? I am Sandeep Giri 9034. There are two separate accounts I'm owning at CloudX Lab. One is Sandeep and other is Sandeep Giri. Sandeep is an administrative account. It can run the administrative functions. It can run any command as any user. So let's say I'm saying sudo, okay? Sudo, let's say at user, like another user like this guy, and then you can see who am I. So when we want to run a command as somebody else, pretend like somebody else, then we use sudo. Like, have you seen in Windows when you right click it says run as somebody else? This is same as that. Okay? If you do not provide this user, it will try to run it as the super user account, which is root. Brilliant. Now, the second question from Veena is, okay, same as run as. Okay. What will be the mapper and reducer in this case when we are importing? Good. So reducer will be no reducer. Okay. That's why in the output folder, you must have seen, uh, if you go here, where was my folder? Not this here. So you see that part dash m, right? So the data has directly gone from mapper into HDFS. Otherwise, it could be part dash R. So there is no reducer at all. While mapper is reading data from JDBC into HDFS file. JDBC. So every mapper does not read any key value from the input. It doesn't have any input file. Okay, all it does is it connects to JDBC, meaning our server. There was three parallel connection just now to our MySQL from our MapReduce job. So it reads data from JDBC into and print output. Okay, which is saved into the HDFS. All right. So as I was telling you earlier that, and as I was telling you earlier that the so as I was telling you earlier that mapper can have any logic inside it. It's your program. It can run JDBC connection. It can run anything you wish to do. Okay. Now Sridhar's question is, we should have administrative rights, administrative access to do sudo. Yes. Not everybody is allowed to do the sudo. That's why this account, which is Sandeep Giri 9034, is not allowed to do the sudo. So if I do say sudo who am I, it'll give an error saying we trust you have received the usual lecture from local system administrator. It usually boils down to these things. Okay, respect the privacy of others. Things before you type. With great power comes great responsibility. So even if I, let me try to do, oh, I'm not sure. You are not in sudo or file, meaning you are not allowed to do the sudo. Okay, this incident will be reported. So other users are not allowed to do sudo. Otherwise, the cluster may not run. Some user might delete the whole system, and that's why we have not given the rights to all the users to do sudo. Okay, it's only a selected account. That's why I had to open another terminal. All right, great. Oh, we are already far past our break time. Wow. All right, never mind. So we have successfully imported data from Scoop into HDFS. Now, same way we can load this data which we have just imported into Hive by creating a table. Let's try to do it after the break. Let's take a break of 10 minutes. Back by 10:32 p.m. IST. All right. So I'm back. Should we start now? All right. Can we start now, everyone? All right. So we were able to successfully import one HDFS file into, one table as an SQL. Also, we, I think we can close the terminal. We don't need it anymore. Okay. So, yeah. All right. So we have this open, and inside each of the file, let's have a look at what is there inside each of these files, or we could simply say Hadoop fs minus cat. All right. So you can see that the data has been broken into three tables. Table one. So this is the table one and two and three. Okay. And also it's comma separated. Right, so it imported our table as comma separated. Good. Now there are two questions. One is this. All right, so there are two questions. Can we import multiple tables in once, or can we import entire database in a single shot? Okay, so let's take a look at scoop. So, I mean, as far as I know, Scoop does not provide you those options of importing multiple, I mean, the whole database in a single go. All right. But what you can do is you can generate a lot of Scoop commands from saying show tables, copy all of them, and generate Scoop commands, and then you can do. uh, So you can see here there is something called import all tables. That basically imports all the all the tables from a database. Okay. While import imports only the single table. All right. Good. All right. So those are good questions. Now moving ahead. All right. Now other than this, so we just now imported our data into HDFS folder, correct? Now let's say this data needs to be loaded into our Hive table. Okay, so one way is you first create Hive table, then load the data using our usual means into Hive. Okay, so let's first try to create the table. One way is you create Hive table manually, but that is little error prone. Okay, that is little error prone, so we will use this. Okay, so we will use scoop command, which will query this particular table, and then it will create Hive table. Okay, you can see that using the login password which we have talked about earlier. All right, now here we are. So let's go here and create a Hive table. Let's see what happens. So it says loading uploaded data into Hive, which means if I run Hive right now, or if I run Hive right now, what does it say? The permission for me in this place is denied. Okay, so we will have to solve both the problems. Right, we will have to again go through the same route. So sudo -u hdfs, and then we are saying hadoop fs minus move /tmp hive to /tmp hive old. Move would be, I think move would be mv. Okay, now I've just removed this folder called hive because it's a temporary folder. Hive should again create this folder. Okay. Okay, so it has created this. Let's have a look at let's just hope it works. All right, Veena, regarding HBase, I will come back to it quite soon. So you can see show HBase, and here I think there would be a database. So here you can see show tables. This widget is containing our will contain our database. Right now it doesn't have any data. We have just created empty table. So using this command, we were able to successfully create an empty table. All right. So now we were able to successfully create an empty table in Hive. And why did we do that? We could have created by manually, because it's better to infer the column data types using the database rather than you manually creating. All right. Now, if you go inside Hive, you can say things like this. What will it do? It will load the data from widgets folder into widgets table. Okay. Now let's have a look at select star from widgets. You see that? It has created the data, just that it has taken those null records also. Because I think these files contained extra empty lines. That's why it has done that. Okay, so it has created null records as well. All right, so we were able to successfully load our data into Hive, as well as, so in the first step what we did was we copied the data from MySQL into HDFS. Then we created an empty table in Hive based on our MySQL table, and then we loaded our HDFS data into this table, right? So that way we understood how to do it in two step. If you want to do it in a single step, it will be far more easier to do. Okay, in a single step it would look like this. It'll look like this. I'll just change the URL. So here we did in two steps. First, we copied three steps actually. First, we copied the data to HDFS. Then we created Hive table. Then we loaded the data from HDFS into Hive table. Now, if you want to do it in a single shot, that's quite straightforward. All right. So let me just copy the login password. Okay. So let's try to do that. All right, and as well, let's go back here, go to my terminal, and first delete the table. Okay, drop table, so the table which we just created, so that I can demonstrate to you. Okay, so we can exit here. So we were able to successfully delete the table, as well as we can also check if it is there or not. Widgets table is there or not. Okay, it is there. Let me see if it is, contains files or not. Alright, the files have been moved and deleted actually, because as I was telling you, whenever we load data into Hive, it moves data in HDFS. So it moved this data, and when you drop the table, it dropped the data. Okay, so now let's try to execute SQL command, so that in a single shot called import, we will be able to copy the data into Hive. Here the important point to note is Hive import. Okay, it's Hive import. All right, there we go. So we are saying scoop import, and then we are saying minus minus Hive import. So it says the output directory called widgets exists. That's correct. Let's remove that rm minus r. Okay, so we have removed the output directory. Okay, so it has created our table. Let's have a look at it. Select star from widgets. Okay, so it has loaded the data, and I'm still wondering why it is creating these empty folders. All right, so we have successfully created these tables. All right, in the Hive. So, okay, so let me parallelly keep drawing here. Show sketch. So we were able to do MySQL to HDFS, MySQL to Hive. Okay. Now we will do MySQL to HBase. This is what we are going to do. Okay. The question from Shishant is, can we import very large tables and using Hive like this will improve performance? Yes. So we can import very large table using Scoop at a very fast rate. And using Hive, when you want to churn data, Hive is generally pretty good with when the data grows into a huge size, and specifically in the cases where data is so this is specifically when when the data is mostly read only. Okay, so Hive is generally used in those cases. Now let's try to do. So we did in two steps. Hive one we did it in two steps using directly or using Hive import. All right. Now, so we have okay. So all right. So now let's try to import a table into HBase. Okay. Let's try to import a table into HBase and see the result. You can see we will use this URL. So here we are saying scoop import connect to this database. Up to here it's same, and then we are saying this particular table that is also same, and then we are specifying HBase related information. Okay, we are saying import this data in this table into HBase table. Now if this table does not exist, it will create this table. Okay, and sorry, I think we have to create this table. We'll just try it out, and we have to specify the column family cf1, and let's just put the username. I'm not sure if it will create. I think we give an error saying that you have to create this table, and also see that we have to provide the columns. Now question to you is, what is it we are doing here? We are taking the data from these columns id and widgets, putting it into customer. Okay, and then putting into customer and in a column family called cf1. If you remember our discussion on h1 hbase, so in case of hbase you need to import data, so whenever you have to create data you always create it inside column family. You have to mention the column family name. That's why you have to specify which column family do you want these columns to be added. Now question arises that what if we have multiple column family? Okay, in those cases you can use scoop import multiple times. All right, you can use scoop import multiple times. All right, now let's try to see if it works. So it says column not found called widgets. Okay, in our table it could not find the widgets column. So we will connect once to MySQL. All right, okay, and say explain or describe. I think it's describe. I actually don't remember widgets. Use default. No, use scoop ex and say explain. Explain what? Or describe widgets. So you can see there is this widget name. So here we can say id is the column name, and let's say these are going into this column family. Okay, and let's say rest of the things like price, design date, we want to put it in another column family. Okay, so we are going to say price, let's say this one. Okay, so widget name goes into one column family, price goes in another column family, and design date. Okay, so let's try to execute these commands and see if we are able to run this. Okay, so I'm just going to and see what error do we get. So it's saying creating missing table from here, created the customer table. Okay, all right, it has retrieved the three records. Let's check our HBase. Okay, let's check our HBase and see if things are okay or not. So we can say list and we can say scan customer. Now you can see that there is a column family CF1. Column name is widget name. In that we have put SP Rocket, Gizmo and Gadget. It is same as what we had put in our here. Okay, the data which we had, you see, Gizmo, Gadget, SP Rocket. Yeah. All right. So it has imported data into the table. Similar way we can import the other values, but this is going to give most likely error because this column family 2 does not exist in our table, and it'll say it doesn't exist. That's why you should upfront create HBase table instead of letting this guy do it. Okay, so let's see if it does anything. It says creating missing column. Oh, nice. This is Scoop has created the missing column family. Okay, it has created missing column family for us. Good. All right. So it's doing the job. All right. Now you can say, let me just start with HBase shell and check if this data, how does the data look like. So you can see that imported some columns in one query, some columns in another query. Okay, now let's just do a scan. What was that? Customer. You can see that it has imported price. Also, one more thing you have to note, whatever columns you want to consider as the row key. So if you remember our H-based discussion, while understanding H-based table, we talked about row key and column key. So you have to specify row key. If you have an ID column, generally it will pick up that ID column values and convert that into row key. Okay, so based on the row key, it will try to figure out the columns. So that brings us to the reason that we have to have we have to have a column in our MySQL database which can be considered as the row key. Okay, all right. So we were able to successfully do the HBase. All right, good. Now next, moving on. Now next, moving on here. So all right. So now let's say we want to take the data from Hive back to the MySQL. Okay, we'll try to do that after this. There are two more questions I need to uh, answer. One question is from Sushant. Can I write a tool which will import data from SQL dynamically and does data churning on demand? Can I write a tool which will import data from SQL dynamically and does? Yes. All right. So you can write a tool which will import data from SQL dynamically and does data churning on demand. Yes. So when you say dynamically, as in on whenever needed, right? Whenever you need, then you can load the data, right? So for that, you can basically, yeah, while using the Hive, okay, you could use different what do you call different import catalog, different catalogs. Okay, using different high catalog, you can actually read from MySQL and do the data churning, and get it done. But this will be fairly ineffective. Okay, because the distributedness will be your MySQL will be the bottleneck because multiple systems will try to call your MySQL or your database. It will get too many connections and it won't be too effective. So all right, now there is a question from Veena. Is there a way to import entire HBase? And how do we go about column families? Yes, so entire HBase is so straightforward. Okay, so the way you do is you break down your table into query sets. Okay, multiple query import. So you can't import even a single table in a single shot. You will have to break down your command into multiple commands, one command per column family. Okay, so you can see that we have defined that CF1 will get these columns and CF2 will get these columns, and that too in two different commands. Okay, so you have to, while importing the data into HBase, you have to write it this way. And for that matter, we generally don't have this problem of uh, generally we don't have this problem of too many tables, because you can always copy the entire list of tables and write a small script which can run this SQL import command for all the tables. All right, you, because it's not straightforward, you cannot take a table and put it in HBase. Why? First, every column has to be inside a column family, which you cannot infer from the given table. Second, every row has to have an ID, the unique identifier, which need to have either the name as ID or need to be specified. Therefore, it requires a little manual intervention to take a MySQL database into HBase. All right. Now let's try to take Hive database back to MySQL. All right. Let's create a simple file. Okay. I'm going to create a simple file like here. And where was the? All right. So let's try to create. Let me exit from here. All right. So we are saying cat angle bracket saying sales.log, meaning whatever comes from the std in, whatever we type in here will get written into sales.log. This is what we are doing as part of this. So, and then we are saying this is our data. Okay, this is our data. Now we can see cat sales.log, then you can see the data. Now we create a table in Hive. We create a table in Hive and then load data from this file. Okay, we'll create a table in Hive and then load data from this. Okay, so you start Hive. Okay, so where is the, what happened to this? All right, so sales table has been created. So let's see what is there inside sales. There's nothing. All right, so now we can load data from local into sales. All right, now the, so you can see that data has been loaded into Hive. Now this is the data which we want to take it to the to MySQL. All right, let's start doing that. Okay. All right, let's try to, not this part, but this part. Okay, also in the meantime you will have to log into MySQL. Okay, and there you will have to um, create this table first. Okay, so we are trying to create a table in, okay, not here but here. All right, so let's say we are using our own database. All right, now let's create a table that we plan to do. Where is the table? Yeah. Okay, done. And So there'll be this table, and again, actually there was a SQL running already in the background. Now let's try to import this. Let's correct the query. Says scoop export. Export means whenever we talk about scoop, we are talking with this as if we are standing inside Hadoop side. Okay. So export means exporting data from a scoop to MySQL. So we are here at, let's modify the URL. So we are saying, because our these servers are new, so c.cloudxlab, number of mappers, we just want to say one. Table name is sales. Export directory, this is where the data would be there. Input fields are separated by comma, and our password and user is different. This is our username and this is our password. Okay, so this way we can export data from Hive into the MySQL. Okay, so let's try to run it from here. Okay, so again, even in the export, it's using the MapReduce. Okay, so you can see that the MapReduce is running now. So let's try to see what is there inside the output folder. So select star from, what was the name of the file? Sorry, we have to go to MySQL and say select star from sales. Alright, so you can see that the data has been exported from Hive into the MySQL. Okay, so in the same way, you could do the export from HBase into MySQL, and from HDFS into MySQL. All right, so that was the scoop we wanted to talk about. Now next is Flume. So this was how do you interact with. So any questions at this point? All right, so what exactly are we doing? So we have exported data back from SQL, which means from this side to this side. Not here, this side to this side. Okay, good. All right. So we use scoop when we have to bring data from MySQL into Hadoop. And what if our data is in various kinds of format? Let's say you have got a web server and you want to push the data continuously. So 2 points. One, when the data has got velocity. Second, the data is in many forms. In those cases, you use scoop. Okay, sorry, in those cases, you use Flume. Now, Flume is made up of many agents. So I'll tell you exact use case scenario for the Flume. For Flume, imagine that you have many servers running the website, and all you want is continuously push all the error messages into a central location. Okay, and generally the central location is your HDFS. So all these all these web servers need to push the data to the HDFS. Now, how do we do that? Generally, web servers are many in I mean, web servers are may sometimes go up to 100 in big large companies. So what will you do with the, how would the Flume work? So Flume will be running, or Flume agent will be running on each machines, and these agents will send the data to the HDFS. Okay, so what is Flume? It's a distributed, reliable, and available system efficiently for efficiently collecting and aggregating and on moving large data from many different sources into HDFS or any centralized data store. Okay, so you can see that there is a web server on one end, and then there is a Flume agent. Flume agent is stored on one machine, and then there is HDFS. Okay, now what does it mean by an agent? An agent is comprised of three things: source, channel, and sink. All right. So what does it mean by a source? Source is kind of a socket. The best example is in case of a USB cable. You can see that there's a micro USB cable here. On one hand, you have source as in the power source, and sink as in the destination. If you have used power bank, you must have realized that there are these power banks has, when you have to charge a power bank, you have to attach the sink side to the power bank. If you want to charge your phone from the power bank, then you attach the source side to the power bank, right? In the same exactly same manner, you have you have this you have this Flume agent. Flume agent is basically a connector. It reads the data from the source and writes data into the sink, and everything in between. The transient in the when the sink and source have different speed rates, that is that is taken care by channel. For example, in this diagram, sink is consuming data at 60 MB per minute, while source is generating 1 MB per second. So you can see the rate of both source and sink is actually same, but sink does store the data every minute, and while source generates the data per second, so that 1 minute's data will be lying in the channel. Okay, that's the use of a channel. Okay, now you can connect such kind of agents together to create the great grid of agents which can take data from one place to another by the way of these mechanisms. Okay, so by switching the various kinds of sinks, you can create all kind of connectors. You can say that read data from Twitter, save it to SDFS, save it to MySQL, save it to this, save it to that, and all kinds of operations you can do. One sink can sync to multiple sources, multiple places, and multiple sinks can write to a single source. So that's how you can build these complex grids. All right. So Flume supports a large variety of sources. The sources could be commands like tail. What does tail do? If you say tail minus f, you will be changing a file. Changing a file as in when the file is modifying, it's being read by the tail. Syslog. The syslog, as in Unix, there is a syslog which keeps generating the logs, or log4j. That's a Java way of logging. So source can read from any of these places and then put it into the channel, and then it gets synced. So Flume nodes could be arranged in arbitrary topologies as I showed you in the previous slide, and typically there's a node running on each source machine with the tiers of aggregating nodes that the data flows through its way to the HDFS. Okay, now that's how we run. So let's have a quick demo of how does Flume work. Okay, let's have a quick demo of how does Flume work now. So all right, So we have a flume dot properties. Now where is the this? Okay. Now if you have not taken out this data here, where is my config by the way? All right, let me just download it. Okay, let me just Hadoop fs minus ls. It's in the data folder. I've already uploaded it into the data folder. So inside Flume, it would be there. Yes, that's my configuration. Let me copy this data to my local folder on that particular machine. Copy to local. So this folder is copied here. So you can see cd conf and you can see flume.properties, flume.properties.out, and let's have a look at flume.properties. Okay. Now, I think you can use nano if you don't like VI, if you are not comfortable with VI, because VI has got little learning curve. Okay. So here we are. So this is how our Flume properties look like. What does this do? Using this, we configure the agent, as in what is it this agent going to do. So we are saying agent called A1 has got only one source called R1. It has got one sink called sink. It has got only one channel called C1. Now you can have multiple sources, multiple channels, and then also, if you have say hundreds of agents, you can define all of that into this single properties file. And while running it, you will say that I'm talking about only first agent called A1. You could have A2, A3, A4, and so on in the single Flume property file, which you will copy to the whole entire cluster. Okay, so this is what we're going to do. So we just defined that a, we told A1 that these are your sources, sinks, and channels. Now, what is the meaning of R1? We are defining. We are saying R1 dot type is netcat. It netcat means it will start listening to this port. It will start listening to this port. Okay. Now that's our definition of the source. Okay, now we have the sink type. Where does it need to store data? Let's try to store data at some location which we are aware of. Okay, so let's try to store it. All right, what is my folder name? User slash, what is the username? This is my username. So here let's say flume data. Okay, that's the place I want to store the data that is coming in. All right, also there are a few more things I wanted to tell you. Then we describe channel. We tell that it's an in-memory channel. That means it won't store in the disk. The capacity, how is the maximum capacity size? Then transaction capacity, how many transaction can it have per second. Now then we bind it. We tell that we also inform channel. We also inform source about its channel and sink about its channel. So we connected the R1 dot channel equal to C1, and then the sink dot channel equals to C1. We informed both of these about each other. Now about the channel. Okay, yeah, thank you, Randhir. Yes, we need to change the server names. and let's say we call it a.cloudxlab. The new, either you could say H1 or A. It's the name of the same machine. Okay, and done. Now let's go back to the, all right. Now let's run it. We have defined all of these things. Now let's try to run it. And also note here that, let's note here that we are explicitly saying the name of the agent is A1. So configuration file could be common to the whole network. So you could copy this configuration file to all the nodes, and then you could say, okay, so and then you could run it from the command line like this. Okay, we were inside the configuration folder, that's why it gave error, because our locations were wrong. Okay, it says it's already in use. So what was running on this? PS, or should we just increase it by one? Let's just increase it by one. Okay, or PS minus U. I can't figure it out. All right, no, it's not there. Let me just pick it. Okay, so where is that? What was that? We were planning to change this port to some other port. Let's say 5. Okay. All right. So it has started. Now we can open another terminal and start. We can talk to this. All right. So this is another terminal. So one terminal is running our Flume agent. Now this Flume agent has started source. The source is listening for particular port to which we can write stuff. So we could say ANSI localhost, and then we could say things like 44445. I think this one needs to be changed. 127.0.0.1. Okay, now whatever we write here is going to go into HDFS. It's being updated continuously in the HDFS. So we could go to Hue and take a look at it. So whatever we write here, so this is program. Right now, I am that program who is generating the data. The data is going to the Flume, and Flume is pushing it to HDFS. Okay, the Flume is pushing it to HDFS. Okay, let me log in into my own account. All right, let me try again. Will it work? Yeah, it did work. Now we go to the file browser. So whatever data we are writing there on the console it is coming here. So what was my Flume data folder? You can see that it is coming here. Okay, every time I write something here, it keeps going to the HDFS. Let's keep going continuously to HDFS. You can see that the files are being created uh, continuously in this folder. Okay, so you could see this is in the byte format, as in you can see it's a byte writable format, so you could load it using MapReduce and churn this data. Okay, so this data is being pushed into by Flume into the HDFS. We are writing here. It could have been some other program who is writing onto this port. Okay, for example, if not us, let's say I say cat sales.log, and then I say what was the port number? All right, it is sent to this table. Okay, so I have sent that data here, whatever is was there in that sales.log. So you can see that Los Angeles, whatever data we were creating there, it has come here. Sounds good to you? All right. So that was a demo of Flume and Scoop today, and we also talked about the Spark streaming. All right. Rest of the things, understanding Uzi and Mahoth and NoSQL databases, we will talk about tomorrow. Okay. So tomorrow we are going to talk about number one, Uzi, two, Mahoth, and three, the third one which we are going to talk about NoSQLs, and fourth one we are going to talk about project. All right, these are the four things we will talk about tomorrow. The question from Randhir is that why is the size of the file so small? Because Flume pushes the data continuously into HDFS so that let it be small files rather than big file but being written by somebody. Okay, so that your program can continuously consume from this folder and do some real-time analytics. Okay, this can be configured at the Flume sync level. You can configure the sync and tell that create this big file. Okay. Yes, Randy, we will be just walking you through machine learning tomorrow. While talk about the Mahat, we will talk about machine learning. Okay. Okay, so a question from Praveen. What's the best way to process? You mean to say, what's the best way to process using MapReduce, the XML file, formatted file? Actually, all three, Hive, MR, and Pig, all three provide you a way to XML format. You need to know about XML input format. We talked about it in the beginning. Have a look at it. Okay, there is a way to handle XML input format. Also search a little bit about XML input format. Okay, so there is this XML and Hadoop. All right, it's basically a Mahod's library which does a lot of work. Okay, you could have a look at it. So that's pretty much about it, and thank you very much. All right. Great. We will talk about these remaining topics tomorrow. All right. Thank you very much.